All right, hi you guys. I'm coming to you with just a little overview of like what you're going to be doing this chapter. It's really the same concept over and over again. So if you can grasp the way of graphing parabolas, I think that will really help you and you'll be successful. So the first thing I could just kind of want to talk to you about is what is a parabola. So parabola is going to form a U shape. And it might go up or it might go down. And we'll talk about like why, how do you know it's going to go up or it's going to go down? So I think of this as like a happy face, and this is like my sad face. And why would it be happy versus why would it be sad? And we'll get into that in this one here. But what I first want to do is talk to you about this thing called a parent function. A parent function is just basically like the most basic type of parabola. Because usually you're going to see something like this, ax squared plus bx plus c. You're going to see a quadratic that looks like that, okay? But if you didn't have, like, let's say your b value is 0 and your c value is 0, you wouldn't have any of this stuff. So you would just end up with ax squared. And in this case, a parent function, your a is 1. Okay, so I'm going to go ahead and graph that over here. So if our a is 1, we're just going to go ahead and plug in some points here into x and solve for y. So if I plugged in 1 squared, so if I make like an x and y table, okay, now we won't have to do this all the time, but I just kind of want to show you how it's formed and the pattern, because if we know the pattern, we're going to be able to go ahead and graph it with that pattern every single time we're having to graph a parabola. So if I plug in a 1 here, 1 squared is 1. If I plug in a 2 here, 2 squared is 4. If I plug in a 3 here, 3 squared is 9. So if I were to go on and on forever, it would be 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So I could go on and on forever. I can plug in any number I want for x and solve for y. Okay, so and then I didn't put in the most important one, which is 0. So 0, if I plug in 0, 0 squared is also 0. So I start at 0, 0. And then here's the pattern. If I went over 1 and up 1, over 1 and up 1, there is my point 1, 1. Over 2, up 4. So over 2 and up 4. There's another one. And over 3 and up 9 will get us to right here. Now, what's cool about a parabola is that it is symmetrical. Just like, think of like a butterfly being symmetrical. It has the same sides. So if I know that it's curving up this way, and this is my starting point, then that means this thing right here, which is this thing right here, is going to be our axis of symmetry. So it's the line that cuts the parabola in half. Okay, and that line is where the vertex is. The vertex is, and I'll put the name of that right here, vertex is the starting point of our parabola. And whether it's going up or if it's going down, it's where that curve starts or where that curve happens, okay? So because of the axis of symmetry, we know that if we went over 1, up 1 that way, we're going to go over 1, up 1 this way as well. I can also use this axis of symmetry to go, okay, if I go over 2 this way, I'm going to go over 2 this way. And then this one is over 3 this way, so I'm going to go over 1, 2, 3 this way. And now I'm going to go ahead and create my curve. There we go. Okay, so I just created my parabola by using the axis of symmetry. So I went over 1, up 1, over 2, up 4, over 3, up 9, and I went this way as well. So you'll see that it has the pattern 1, 1, 2, 4, 3, 9. That's really important as we move forward with graphing. Okay, so how do you know a parabola opens up or down? Okay, so if your A is basically 1 or greater, so greater than or equal to 1, it's going to be a happy face because it's positive. Okay, if A is less than or equal to 1, then it's going to be facing down. So I kind of do this. If A is negative, it's going down. If A is positive, it's going up. Okay, so that A value is really what is going to tell you if it's an upward curve or a downward curve. Okay, how can you tell if the parabola will have a skinny, wide, or normal opening? Okay, so let's first talk about a normal opening is 1, 1, 2, 4, 3, 9. It follows this pattern. This is a normal opening. Okay, but if it's skinny versus wide, okay, so let's look at, let's say we changed the A value to, let's say, a 5. If I plugged in a 5 here and I had the 1, 1, 2, 4, 3, 9, what would happen is that all of these would jump up by multiplying by 5. And when we multiply 4 by 5, we're going to get 20. So we're going to go over 2 up 20. If we multiplied 9 by 5, we'd go over 3 up 45. And that would make it really skinny. So when you have, let's see, A is greater than 1, that means it's going to be a skinny graph. So the bigger the number, so let's see, I'm trying to think if I could put it somewhere. So bigger A value. So the bigger A value is going to be skinny. The wider one is when you're going to have fractions. So you're going to have, now I don't want to say less than 1 because we can't have negatives. Well, I guess we could. We just would, that negative is telling us it's going to be down. So I guess we'll just do less than 1, okay? And this one, I always put that it's basically going to be a fraction. So when you have a fraction, it's going to be wide. When you have a number bigger, the bigger A value, so like 2, 3, 4, 5. 5 is going to be a really skinny graph. 2 might be kind of a skinny graph, but not as much as the 5. So this is all focused. Both of these are looking at your A value. Oops, let me move that over just a little bit. Okay, so focusing on your A value. Then what is the axis of symmetry? Axis of symmetry, which we abbreviate by AOS, is the line. So this is a line, not a dot. This is not a point. This is a line of symmetry. You can say that it cuts parabola in half. Okay, the next one is the vertex. The vertex is an x comma y point, and it's the maximum or minimum point of the parabola. So if you think of a parabola going up, it's going to be the point right there, which is, oops, I'm so sorry. I just realized that I'm off the paper here. Okay, so the maximum or minimum point of the parabola. So when we're looking at something like this, okay, this is an A value of 1. So this point right here is going to be your minimum value. So if you go here, that's your minimum. If you think of here, you're on top of a mountain, so that's your max point. So if you think of throwing a ball in the air, this is going to be the maximum point at which the ball is in the air, so the maximum height. This one here, if you think of like a dolphin diving into the water, this is the lowest point that they're going to hit. So how do you find other points on the graph? So again, a lot of times you'll find the AOS. So steps would be find your AOS, then find your vertex, decide on if it's going up or down, so maximum or minimum. How are you going to do your curve? And then when you're doing your points on the graph, which we will learn later, there's a pattern. And it will be, again, 1, 1A, 2, 4A, and 3, 9A. And A represents the value of A in AX squared plus BX plus C. Okay, so that's where your A comes from. And basically you have to multiply that, because if your A is not 1, then you might end up with either a skinny graph, a skinnier graph, or a wider graph, depending on what your A value is, okay? So what is the y-intercept and how do I find the y-intercept? So your y-intercept is always going to be where it crosses this y-axis. Where does it cross? So in this case, it's 0, okay? And the reason why it's 0 is because it is your c value. In this case, we had no c values. C value was 0 because you only had an x squared. So your a is 1, your b would be 0, and your c would be 0 in a parent function. Okay, so over here, your y value would be 0, comma c, and it's where the graph crosses the y-axis. Move that over. There you go, where the graph crosses the y-axis. And then the last one we're going to look at today is how can I find out the x-intercepts? Okay, well, let's go back to the graph. Remember that your x-intercepts are where it crosses this x-axis. Okay, and we've learned that we could do quadratic formula, we could do we could do solving by factoring, we can do completing the square, but we can also, now that we have a graph, we can look at where does it cross the x-axis. So if I look here, I can see that it crosses the x-axis at 0, 0, and it only crosses one time. So my solution here would be 0 because that is the x-axis that I'm crossing. Okay, so how do you find out the x-axis? Look at graph and see where it crosses the x-axis. Okay, so let me move that up just a little bit. Look at the graph and see where it crosses the x-axis. So remember the x-axis is here. We'll call this the y-axis. These are your points. In this case, I just drew a picture of something where it has 2 x-intercepts, okay? Whereas we just drew a graph where it only has 1 x-axis. So this is just an overview of the chapter. We will get to more graphing and stuff later. And just to let you guys know, this paper does have like one extra problem here, but we're not going to go over that for today. We're just going to stay fairly simple, okay? So I hope this video helps you, and if you have questions, come see me on our Zoom meetings.